Okay, this is our question about calculating the voltage across and charge stored by each capacitor. So here are the capacitors here. So you've got a 25 volt supply, and then you've got these other capacitors here. So again, we're going to do equivalent circuits. So my first equivalent circuit would just be to get these all looking quite straightforward. In one string, then on the other side I'll have my supply. So C1, C2, C3, C4, C5. My supply is staying the same as being 25 volts. So my first step in my circuit reduction will be to get rid of C2 and C3. So I'm going to replace them first. So I'm going to go from that to an arrangement like this. Nope. Hang on. So C1 is still the same, C4 the same, C5 is the same, but now C2 and C3 are replaced by this capacitor here. We'll call it CS for capacitors in series. And to work out the value of CS, you've got a 4 and a 4 in series, which you work out as if they're in parallel. So you'd use a parallel resistor technique, if you like. So when capacitors are in series, you treat them like parallel capacitors. So you would do 4 times 4 divided by 4 plus 4. And my 4s are coming from these two 4s here. And that gets me a value there have been 2 microfarads. These are microfarads, so this is microfarads. My next step is going to be to take these two, CS and C4, and put them into an equivalent. Let's move that down. So I can still see that. Got my C1. Call this CP and C5. Capacitors in parallel, you treat as if they're like resistors in series. So if you had a 2 and a C4, C4's value was 6, wasn't it? 6 microfarads. That's it there, 6 microfarads. So when they're in parallel here, you treat them like series resistors, so you're just going to add them together. So our CP, which is the replacement of what's in the yellow there, would be 8 microfarads. Just by adding the 2 and the 6 together. And that's that there. My C1 and C5 have stayed the same values. C1 was 6 microfarads, C5 was 3 microfarads. So I can go from that to my final equivalent circuit. Now, because you've got 3 rather than 2, you can't use the product over the sum. Because you've got 3 rather than 2, you've got to use the 1 over method. So 6, 1 over, plus 8, 1 over, plus 3, 1 over. And you can use this method for 2 resistors, 3 resistors, 4. Doesn't make any difference, or capacitors. Then a final 1 over, and convert that into a decimal, 1.6. So 1.6 microfarads, 25 volts. So on this circuit here, I can work out what my Q is. And Q equals C times V. I'll put that in my original sheet up here at the top in my wee triangle. So Q equals C times V. So it's 1.6 times 10 to the minus 6 for my C, My V is 25 volts. And I'll engineer that. So my value for Q is 40 microcoulombs for charge. So that'll be the same as for Q1, 40 microcoulombs there. And it'll be the same for Q5. And you'll have 40 microcoulombs in this parallel part. Using this 40 microcoulombs, I can then work out my voltage across capacitor 1 by doing V equals Q over C. So that 40 microcoulombs divided by 6 microfarads. That's a repeater, 6.67. V1. Voltage across the parallel part. I'm going to use that 40 microcoulombs again. Forty microcoulombs is from here, divided by my capacitance on the parallel part. Oops. 40 microcoulombs divided by the capacitance, which is -6 as well. Gets me 5 volts. My V5. And use my 40 microcoulombs again. My V5 is 3. 3 times 10 to the -6. Gets me 13.33. And when I add these three values together, I should get my 25 volts. To tie in with my 25 volts there. So I've got my charge for Q1 and Q5. Just really be looking at this circuit. My voltage across this one, my voltage across this one, and my voltage across here. Now, taking it a step back, looking at this circuit here now. So that circuit there. So my voltage across my parallel section, 5 volts. So I've got 5 volts across here. So using that 5 volts, I can work out the charge stored by CS and C4. So I'm going to go for QS, and Q is C times V. So QS, 2 times 10 to the -6, times 5. That's going to be 10 microcoulombs. And Q4, it's going to be 6 times 10 to the -6 times 5, 30 microcoulombs. And that 10 and that 30 add up together to give you that 40. So I've got my 10 and my 30. Now using this 30, I can get my V4. Because I know that V equals Q over C. So Q over C. So 30 times 10 to the -6 divided by C, the value of that capacitor, Q4, C4, 6 microfarads. Five volts, as it is here. So that's 5 volts. Didn't need to do that. And I've got my CS now. So now we're back to this circuit here. So I know my Q for QS, which is for 2 and 3, is that 10 microcoulombs. So I'm going to use that 10 microcoulombs to get my voltage 2. By doing Q over C, Q, 10 times 10 to the -6. C for C2, that was originally 4 microfarads. That gets me 2.5 volts. My V3 calculation will be exactly the same, won't it? Q divided by C is the same charge because it's in the same series string. Charge is the same in series. And my capacitor, it's the same value because C2 and C3 are both the same value. Okay, so I should have 5 voltages and 5 charges. So I've got voltage 1, voltage 2, voltage 3, voltage 4, voltage 5. I've got Q1. I have QS, which is the same as Q2, which is the same as Q3. I have Q4 and I have Q5. So there are all the charges and all the voltages for this circuit.